Is AI engineering just a fad, or is AI going to replace you? If you are in tech in the USA today and have considered pivoting to AI engineering, you might be feeling overwhelmed. Because today everyone's definition of an AI engineer seems different. Everyone is adding AI enabled to their LinkedIn bios. And that doesn't help that AI is entering JDs faster than product can say is just a small change. So you might be asking yourself what actually matters to become an AI engineer in 2026. Hi everyone, I'm Ranajit. I'm a staff machine learning scientist developing generative AI and agentic systems. Previously, I have worked with Microsoft and Samsung Research. In my free time, I talk with different engineers, and every week I speak to different developers who are trying to transition into AI roles. In this video, I'm going to walk you through the fastest path becoming an AI engineer in 2026. No hype, just the roadmap modern AI systems actually require. We will cover what the market for AI engineers actually looks like, the core capabilities of modern AI engineers need, and the fastest way to build those skills so that you can design systems that work even when the models fail. Let's dive in. Before we get into the roadmap, let's discuss one important question. How many jobs really are there for AI engineers? As per January 2026 report by LinkedIn, there are over 104,000 artificial intelligence jobs worldwide. AI engineer roles have surged 143% year over year in US postings, creating 1.3 million new global AI positions recently as per LinkedIn data. In the market where layoffs dominate the headlines, it's important to also look into the actual stats, and according to LinkedIn, these stats are definitely in our favor. Let's talk about the capabilities that matter in 2026 because many engineers spend time learning the wrong things. The first capability is tool building. Modern AI systems rely heavily on tools. Agents often need to query the database, call the APIs, trigger some workflows, and interact with external systems. But tools designed for AI must be structured differently than traditional APIs. They require clear schemas, structured input, permission boundaries, and descriptions that model can reason about. Without this structure, AI systems behave unpredictably. So the first shift in your roadmap is simple. Stop thinking about AI as chatbot and start thinking about it as a system that interacts with different tools. This means learning how to build structured APIs, function calling interfaces, retrieval pipelines, vector search systems, and tool registries. The second capability is orchestration. Once tools exist, agents need to decide what to do next. Should the system retrieve more context? Should it call a tool? Should it retry the task? Should it escalate the request? Production AI systems solve these decisions using orchestration. Instead of a simple pipeline like prompt, model, output, modern systems operate as decision graphs with loops, retries logics, and branching logic. Frameworks like LangGraph allow engineers to define the agent state, the execution flows, tool usage, rules, and error recovery. The third capability is AI reliability engineering. Because once an AI system works, the real challenge becomes keeping it from breaking. AI systems fail in ways transitional software never did. Models hallucinate, retrieval pipelines fail, agents loop repeatedly, context windows overflow, tool returns unexpected outputs. Which means modern AI engineers must think like reliability engineers. Production system requires monitoring, evaluation pipeline, guardrails, fallback strategies, confidence scoring, and human-in-the-loop escalation. To understand why these capabilities matter, let's look at a typical AI production workflow. A user asks a question. First, the system calls a retrieval agent that searches the database for relevant documents. Those results are passed to the reasoning agent that decides what to do next. If the external data is required, the agent calls tools through a tool execution layer. A verification step then checks whether the output is valid. A monitoring system logs the entire interaction. If the system fails, the workflow retries or escalates. That's not a chatbot, that's an AI native software system. And designing systems like this is what AI engineering is really about. If you're serious about becoming an AI engineer, the best way is to get off YouTube. But before you go, finish this video first. Don't do it alone. Don't spend hours figuring out what to learn next. And don't risk getting stumped in an interview because it couldn't explain your AI project. Interview Kickstart pairs ambitious developers with experienced mentors, and its agentic AI program has been getting great public reviews. Let me get one that caught my eye. So Kyle, who started the Applied Agentic course last year, says the courses are excellent, hands-on, in-depth, and packed with material. There is a lot to cover, so you really need to stay focused to get most out of them. I am on my second course now and couldn't be happier. If you guys want to check this program out, I'll leave a link to the free webinar Interview Kickstart team host. You can come and meet the team and see if it is a fit for you. Now, if you want to do it yourself, here is the roadmap I'd recommend. It is based on one you would learn at IK, but of course without projects. How a 3-month roadmap will look like. During your first month, focus on AI application foundations. How modern AI applications interact with language models through APIs, simple interfaces. Build small tools that processes structured data and respond to the user queries in a controlled way. Work with system prompts, tool usage, and data-grounded responses so you develop a clear understanding of how a single AI agent receives input, reasons about a task, accesses data, and generates answers. During the second month, focus on knowledge systems and agent workflows. Learn how the embedding, chunking strategies, and vector databases make large collections of information searchable. Build retrieval pipelines that allow models to access relevant documents and generate grounded responses using retrieval augmented generation, that is RAG. Then extend these systems with agentic workflows where models plan tasks, use tools, and execute multi-step reasoning processes. Then in your last month, that is the third month, focus on production-ready AI systems. Learn how to design coordinated agent workflows, evaluate the system performance, and introduce guardrails that guide the model behavior. Implement monitoring for latency, token usage, and cost, and explore how the models affect reliability and performances. This stage brings together retrieval, orchestration, and evaluation into the systems that operate consistently in real-world environments. Now, this is a good place to start. But really the best part of the program is the hands-on learning with projects and support of the Faang engineers who would be teaching you. Some of the learners in IK have also made fantastic videos showing their new skills off. If you want to see that, I'll put them at the end, alone or with Interview Kickstart. Becoming an AI engineer in 2026 is absolutely achievable, but the role has changed. Whether you choose self-study or learn from 700 plus Faang engineers who endorse Interview Kickstart, I wish you all the best. See you in the next video. Unless I see you in the webinar first.